Right. I need $1 million, and the other day I need another $1 million. Okay, give me questions about your homework. Do 10. You just said you didn't have any questions. Are y'all just calling out numbers for the sake of homework? Which one? 11 split upside down, not 10. 11. All right. Let me reel you in, guys. We're doing number 11. Take out your homework. And let's check it. Tell me first off, where is the asymptote here? 5. Y equals 5. Don't forget the y equals because that tells me it's a horizontal line, right? Say right because that's right. Thank you. All right. 1, 2, 3, 4, 5. What's special about this one? It's flip. Is it Florida somewhere? I don't know. All right. Give me a point on my graph. A point on my graph. No. Give me the HA plus K. 0. Oh, that's a nasty one, isn't it? But you're right. 14 over 3. 14 over 3 is almost 5. It's 4 2/3, so 0, 4 2/3. But the nice thing about that is that's also your y-intercept, so we'll figure it out for you. All right, so another point. How might I find another point? What should I plug in? 1. Why 1? Close to 0 is right beside 0. So whenever I plug in 1, I get f of 1 equals negative 1/3. 6 to the first power plus 5. 6 to the first is 6, so I got negative 6 over 3, which is negative 2 is, so what are the coordinates of that point? 1, 3. Y'all got this, sillies. Y'all said you needed help. I think y'all just didn't want to do anything today. Yes. What's the domain? Negative infinity, infinity. It's always negative infinity, infinity for these. How about the range?
Yo, is this about homework?
Exactly. What's it about? Homework. How about the end behavior? As x approaches infinity, what does f of x approach? Negative. As x approaches negative infinity, what does the graph approach? All right, let's move on because y'all are. This one's not as easy. I'll give you.
You got it. I got you, Brett.
Don't rip it. Quit. Enough.
No, it's red.
You better use it. No, you're writing notes on that.
No, it's not a part of that.
All right, we're going to look at 2 different scenarios today. We will tack more. What did you just throw at her? That was at you? I thought you threw it over there. Oh. All right, we're going to look at 2 different scenarios, and then we'll keep adding on to this as we go through this unit. Okay, so today we're going to talk about what happens if we have these equations where my variable's up top in the exponent, and I need to solve for that, and how I do that. So, what? Scenario number 1. This is a Roman numeral 1, by the way. If I start out where the bases are the same initially, okay? Now, think about this for just a second. If I told you 3 to the x equals 3 to the, I don't know, 7th, that's pretty easy. You would tell me what? What does x equal? 7. There's nothing else it can be, right? That's kind of the concept we're going to use here, and that if the bases are the same and I've got them equal to each other, so I've got base exponent equals base exponent, and these two bases are the same, then what I can do is I can just drop them off and set the exponents equal to each other. So in this case, it was really easy because that was an easy one to see, but they might not be quite as easy. So let me show you what I'm talking about. Y'all got that? Wait a minute. Come on. We'll start easy. How might I solve that for x? You are about to get in trouble. I'm going to call your mama. X equals 8. That's an easy one, right? I set the exponents equal to each other, and I solve because the bases are the same. Does that make sense? So, subtract 1 from both sides. That was easy. That was too easy for y'all. What if it looked like this? Can I still drop the bases and set the exponents equal? Yes. So I can still say, well, then that means that 4x plus 5 equals x minus 7. And now I can go through and solve that. What should I move first? The what? The x? Okay. We can move the negative 7 first. I got 4x plus 12 equals x. Subtract 4x. There's not a right or a wrong order to do this in. You could subtract either one. What did you move the x first? Like, did you do this? So if you moved both of them, then you ended up with 3x plus 12 equals 0. And then you move the 12 and you get 3x equals negative 12. You're going to be in the same scenario we are here. If I divide by negative 3, I get negative 4 equals x. If you divide by 3, you get x equals negative 4. So same thing. Either way you want to go about it, doesn't matter. Now, remember I told you this only works when it's base exponent, and these two are the same. What happens if it looks something like this? What do you do? Rewind back to properties of exponents. What do? You add them, right? If I'm multiplying with the same base, I add them. So I'm going to put a note on here that you might need to combine common bases first. Right. Whenever you're doing anything, because this little trick that I'm showing you only works if it's one thing equals one thing, right? And the bases are the same. So x plus 2. Welcome. So yeah. So on the left side here, the exponent becomes what? What's x plus 2? 2x plus 2. All I'm doing is saying x plus 2. Are y'all following me? Yes, Miss McGee, that makes sense. No, Miss McGee, that is very confusing. Now we can set them equal. That's exactly right. So we might have to kind of clean it up a little bit before we can set them equal to each other. So 2x plus 2. equals 5x minus 1. Now I can solve this for x. What do I do first? Okay, so do whichever you want to do first, right? I always move the smallest one first. I would move 2 here probably, but it doesn't matter. But now in this case, I got to move the 5x, right? So I get negative 3x equals negative 3. What does x equal? You're welcome. You're talking about the base? It just goes away. When you set the exponents equal to each other, you ignore the base. But that only works when all the bases are the same. All right, let me show you one more of these because I'm not sure you got it. I'm not convinced. They're not all like this. This is a hard one for this scenario, and then I'm gonna show you. Remember, I'm gonna show you 2 scenarios. I'm gonna let you try this one on your own. I'm gonna let y'all cook. Okay. You're still adding them. Mm-hmm. You're just finding x. That's exactly right. Whatever I get. Okay. Why? So did you get to this point with your exponents? All the way. Why?
Don't even come to school.
Let's do a hard one. Not of the. Let's do scenario 2. That's the hard one. This is scenario 2. Uncommon bases. All right, if the bases are not the same, I can't just drop the bases and set the exponents equal. What I have to do, I call this base manipulation. That's not a technical word, it's just what I call it. Manipulation. Which means make the bases be the same. Well, but here's the caveat here, make the bases the same. You cannot change the value of the number. Okay? So in other words, yes, the square root of 36 is 6, but I can't change the value. At the end of the day, it still has to be 36. So I can write it a different way, but I can't change its value. So how could I write these to where the bases would both be the same? 6 squared, right? Because this is already 6. This would become 6 to the 2nd power. Now I'm back to scenario 1. I can drop the bases off, and I can solve from there. This was obviously a really easy one. You'll be able to on these. And so we're going to talk about what happens. That's when we get into logarithms tomorrow. So we'll talk about what happens, yeah. Logarithms. Logs. Okay. Let's do this one. Now, sometimes you'll have to adjust both. Sometimes you'll just have to adjust one. Just depends, but you really have to look at it and you really have to think about it. It would be a cube. I'm going to have to take something to the cube. So what are you thinking? Talk me through it. 3 cubed. William says 3 cubed. I agree.
I agree too.
3 cubed is the same thing as 27, yes? I have not changed the value of the base. It's still the same. But look at what's still there. It's still got this exponent of 2x plus 6, yes? That's exactly right. That's what I was going to ask you. What do you do when you raise a power to a power and you multiply? So when I drop these bases off, I have to say all of this, which is a multiply situation. So 6x plus 18 equals 2x. Now what? Subtract 2x. I get 4x plus 18 equals 0. Okay. Let's see if you got it.
I got it.
Let's do one more easy one, and then I want to do a hard one, and then I'm almost done. I just want to make sure I address this issue that happens. Well, 7 to the power of 7 is not negative 1. No, exactly. I thought I was going to trick y'all with that. 7 to the negative 1 is 1 over 7. So if you ever need to flip something, remember those negative exponents help you do that. Okay. So I've got 4x plus 11 equals negative 1. I'm just going to subtract that 11. We've been getting 3 a lot today. It's fine. Pick that number on a lottery ticket. What is that? Oh, Brett, that is a very ugly word. Abbreviated it. Tell me what you did. What's your base? What do you think your base is? What'd you say? 3 is the base. 3 to the what is 27? And I still got a 2x there. 3 to the what is 243? Oh, Red! Hughes! I am going to call. We're fixing to call your mama together. 5. Thank you. What in the world? Now I can drop the bases. So 6x equals what? 36. Okay. Y'all are getting this better than any of my classes have done it before. Subtract the 5x. Y'all ready to crank it up? If y'all can do this one, I'll stop. No, this is just a combination of everything. Because I'm L McGee. I have to live up to my title. This Miss Grumpy, that's right. Yes, he did. Yes, good job. So, yes, plus I can. They don't have the same bases. I can't combine them. I can't drop them. So what I'm going to do is kind of a combination of scenario 1 and 2. I'm going to rewrite, combine, and then drop. So over here, you notice everybody's got a base of 4 except for this middle one, but that's easy to solve. I can make it -2. Now what? Okay, combine them how? 2x and -2, and what's it going to equal? 6x plus 8. I think y'all got this. I hope y'all are speaking up if you don't. We graph the exponentials. Because we're graphing exponentials with the x up top and the exponent. We're doing the algebraic side of it instead of the graphing side.